Imagine a world where one side of the planet is permanently on fire, and the other side is frozen in eternal darkness. No wind, no rain, no atmosphere, just a scorching, dead rock orbiting its star every 11 hours. Scientists just found it. It's 48 light-years away, and James Webb Space Telescope looked directly at its surface, something humanity has never done before with a planet outside our solar system. The planet is called LHS 3844b. It's about 30% bigger than Earth, making it a super-Earth. But here's the twist. It's nothing like Earth. Scientists say it looks exactly like a giant version of Mercury. This week, researchers from Harvard and the Max Planck Institute published findings in Nature Astronomy that changed how we understand distant worlds. And before we dive in, here's the big question I want you to think about. If James Webb can read the geology of a planet 48 light-years away, how close are we to finding a planet that can actually support life? Stay with me. I'll answer that at the end of the video, and the answer might surprise you. The discovery. What did Webb actually find? LHS 3844b orbits a red dwarf star, a cooler, smaller sun at an insanely close distance. It's only 3 stellar diameters above the star's surface. That's like Earth orbiting the sun from inside Mercury's path. Because of this extreme proximity, the planet is tidally locked, meaning one face permanently stares into the star and the other is locked in permanent darkness. The dayside temperature? Around 1000 Kelvin, roughly 725 degrees Celsius, or 1340 degrees Fahrenheit. Hot enough to melt metal. Now here's what makes this discovery historic. JWST used its mid-infrared instrument called MIRI to detect heat radiation coming directly off the planet's surface, not just from its atmosphere, from the surface itself. They compared that infrared fingerprint against libraries of known rocks, Earth rocks, Moon rocks, Martian rocks, and the verdict? No silicate crust like Earth, no granite, no plate tectonics, no water signature. What they found instead was dark basaltic rock volcanic mantle material likely covered in ancient dust and space-weathered regolith. Basically, a giant dead Mercury. Airless, lifeless, but absolutely fascinating to science. Visual cue. Show animation of tidally locked planet with fiery dayside and icy darkside. Then zoom into MIRI infrared scan visual. Why this matters? What's the benefit for humanity? You might be thinking, okay, it's a dead rock. Why should I care? Here's why this discovery changes everything for our future in space. 1. We just unlocked planetary geology at 48 light-years. Before this, we could only study atmospheres of exoplanets. Now, JWST reads the actual geology, the rock composition of distant worlds. This is like going from blurry X-rays to full MRI scans. 2. It teaches us what makes Earth unique. LHS 3844b has no plate tectonics, no water, no silicate crust. Earth has all 3. This tells us the combination that created life here is incredibly rare, and understanding that rarity helps us know where to look next. 3. It's a roadmap for finding habitable planets. By ruling out dead worlds faster, JWST can help us focus resources on the planets that actually have a chance of hosting life or becoming future human colonies. 4. Understanding space weathering protects future missions. The surface of LHS 3844b is destroyed by radiation and micrometeorite impacts over billions of years. Understanding this process directly helps engineers design better shielding for spacecraft and future space habitats. 5. It validates our planet hunting technology. The fact that JWST can separate a planet's light from a star billions of kilometers away with parts per million precision means our tools are now powerful enough to detect life signs on Earth-sized worlds. We're almost there. The future light speed travel and becoming an interplanetary civilization. Now, let's talk about the big dream. 48 light-years. How do we ever get there? At our fastest spacecraft speed today, the Parker Solar Probe at 690,000 kilometers per hour reaching LHS 3844b would take over 47,000 years. That's not going to work. So, what are scientists actually working on? The road to light speed travel. Antimatter propulsion. When matter meets antimatter, it annihilates, releasing energy with 100% efficiency. NASA and CERN researchers believe antimatter engines could reach 10% to 50% of the speed of light. At 50% light speed, LHS 3844b is reachable in under 100 years within a multi-generational mission. The Alcubierre warp drive. Mexican physicist Miguel Alcubierre proposed a concept in 1994 that is still being studied. Compress space in front of a ship and expand it behind. The ship doesn't move through space, space itself moves around it. No Einstein speed limit applies. Scientists at DARPA and private labs are still exploring whether exotic negative energy could make this work. Laser sail. Breakthrough starshot. Funded by Stephen Hawking and Yuri Milner, this project aims to fire a powerful laser at a tiny light sail spacecraft, accelerating it to 20% the speed of light. At that speed, a probe could reach the nearest star in 20 years. Technology development is ongoing. We may see a demo mission within this decade. Nuclear Pulse Propulsion Project Orion from the 1950s and its modern successors proposed detonating nuclear bombs behind a spacecraft to generate massive thrust. Theoretical calculations show it could reach 3–5% of light speed. No fuel efficiency problem, just enormous political and safety challenges. How we become an interplanetary civilization. Step 1. The Moon. Permanent base by the 2030s. Mining helium. 3. For fusion reactors. Proving humans can survive off Earth long term. Step 2. Mars. SpaceX Starship missions in the late 2020s. First permanent colony in the 2030s. Mars becomes our backup civilization if Earth faces extinction. Humanity survives. Step 3. Asteroid belt. Mining rare minerals and metals to build megastructures in space without destroying Earth's environment. Step 4. Outer solar system. Europa for water. Titan for its thick atmosphere and liquid methane seas. These become research outposts and fuel depots. Step 5. Generation ships or digital mines for journeys of hundreds of years. Either humanity sends massive, self-sustaining ships, essentially floating cities, or we transmit human consciousness digitally to be rebuilt at the destination. Both concepts are being seriously explored by futurists and engineers. Discoveries like LHS 3844b are exactly what drive this roadmap. Every dead planet we map tells us where not to land, and brings us one step closer to finding where we should. Bonus. Insight. The bigger picture. Here's something even more mind-bending to consider. LHS 3844b is tidally locked. One side always day, one always night. But scientists are now theorizing that on some tidally locked planets orbiting in the habitable zone of cooler stars, there could be a narrow terminator line between the day and night side. A permanent twilight zone where temperatures might be survivable, maybe even where liquid water could exist. LHS 3844b is too hot for this. But the same technique JWST just used here will be applied to planets in the habitable zone of red dwarf stars. There are billions of red dwarfs in our galaxy, and most of them have rocky planets. We are not looking for a needle in a haystack. We just got a much better magnet. Also think about this. The light JWST captured from LHS 3844b left that planet 48 years ago. We are literally seeing its past. Astronomy is time travel. The answer. Engaging the audience. Remember the question I asked at the start? How close are we to finding a planet that can actually support life? Here's the answer. Closer than ever. But not because we found a planet that has life. Because we're learning, world by world, what the conditions for life actually require. LHS 3844b has no atmosphere, no water, no tectonics. It's a negative data point, and negative data points in science are just as powerful as positive ones. Every dead world narrows the search. JWST's successor telescopes, the Habitable Worlds Observatory, planned for the late 2030s, will be able to directly image Earth-sized planets and detect oxygen, water vapor, and even methane in their atmospheres. These are biosignatures, chemical fingerprints of life. We may detect signs of life on another planet within the next 20 years. Not fiction, not fantasy, actual scientific consensus. And when that day comes, humanity will never be the same again. Now tell me in the comments, if you could send one message to any civilization on another planet, what would you say? Drop it below. I read every single one. If this blew your mind, smash the like button, share this with someone who loves space, and subscribe to Nexus Future for every Sunday upload. We are not just watching the universe. We are learning to reach it. See you next Sunday.